Hello guys, welcome to three-dimensional tutorials. Today we'll be doing general solution. So if you want more on our lesson for trigonometry, you can visit my previous videos there. There you will learn more about double angles, compound angles and everything. So in this case, the first question we have cos 2x equal to cos x. We need to find a general solution for this. If you have cos 2x equal to cos x, you see you have double angle and a single angle, and there's no way that we can change the single angle into a double angle, but we can change the double into a single. So our first step is to change this double angle, and we know double angle for cos it's given by these three ways. So if we have cos 2x, it can be written as 2 cos squared x minus 1, or cos squared x minus sine squared x, or we can have 1 minus 2 sine squared x. So if you have this, you have to check here, what do you have? If you change this, can I change into this one or this one or this one? So what I do here is that you check that you have only cos here. That means when you change it to the one that has only cos. So the first one has only cos, this one has cos and sine, this one has sine. So the best one to change to is this one, because it has only one cos. So this you will write this into it. This will be 2 cos squared x minus 1 equal to cos x. So when you have squared here and you have this, move everything to one side. So if we move everything to one side, this will be like this, cos x. But we have to rearrange it to be in this format: ax squared plus bx plus c. So if we want to rearrange this into the format, this will be 2 cos squared x minus cos x minus 1 equal to 0. Now it's in this format. So you can use quadratic equation to get the answers here, or if you know the factors, you can just put them inside. So you either use quadratic formula or use the factors here. So the factors here will be 2 cos x, then here will be cos x, because if you multiply 2 cos x times cos x, it will just give us 2 cos squared x. Then here we'll have plus 1, and then here we'll have minus 1. Since 1 times negative 1, it will give us negative 1. Then we can check if they are correct. 2 cos x times 1, that will be negative 2 cos x. Then if you add these, you'll get negative. So these are correct. So the answers, you'll have 2 cos x equal to minus 1, or cos x equal to 1. So for this one, we have to divide both sides by 2. If you divide both sides by 2, you are left with cos x. You are left with cos x equal to minus 1 over 2. So we have to check here. Cos x is equal to minus 1 over 2. The minus here tells us where is cos negative. So you can do something like this and check where is cos negative, which quadrant. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So which quadrant is cos negative? So we have quadrant 2 and quadrant 3. We know our general solution will be found in these two quadrants, quadrant 2 and quadrant 3. So for this other one here, cos is positive. So if cos is positive, your general solution will be in quadrant 1 and quadrant 4, because cos is positive in quadrant 1 and quadrant 4. So now let's solve this one. We firstly find the reference angle. So finding the reference angle now. Reference angle, you say cos inverse of this number. This will be cos inverse of 1 over 2. The negative was helpful for us to get the quadrant in which cos is negative, but now we don't need it. We just want the reference angle now. So how do you find the reference angle in this case? This will be, you just plug it in your calculator. Let's see. Cos inverse of 1 over 2. So this is, it gives us 60 degrees. So we have 60 degrees as our cos inverse. So in this case, you go to these quadrants that you ticked here. So you can get only one quadrant. You can solve only one quadrant is fine, but if you want all the solution, this is, you can just solve these two quadrants, but it's not a must for you to solve the two quadrants. You can just solve the first one that you see here, which is quadrant 2. So you go and say quadrant 2. Quadrant 2 is given by the general way of writing it. It says what? You'll write the angle, you will write your angle here equal to what? Quadrant 2 is 180, so you'll subtract what? Your reference angle plus 360 times k, for k is element of integers. So the angle here, this is the angle here, in our case that's x. So this will be 180 minus what? Your reference angle, which is 60 degrees, then plus what? 360 degrees times k. So already gave the reason. K is element of integers. It's important for you to tell them what is k. K is element of integers, so that we can have the actual values of this x. So this will be x equal to 120 degrees plus 360 times k. So that's the answer for quadrant 2. We can do for quadrant 3, but it's not necessary for us to do that. Okay, but for learning purpose, let's just do everything. So for quadrant 3, this will be given by theta equal to 180 plus your reference angle plus 360 times k, for k is element of integers. So you have that. Then your angle is x, in this case 180 plus what? Your reference angle is 60 plus 360 times k, for k. Okay, there is no need for to write the reason over and over again, so there is no need for that. So this will give us 280 plus 60 240 plus 360 degrees times k. So this is what the general solution for cos x equal to negative 1 over 2. So remember, we have another answer, which is cos x equal to 1. So for this one, we do the same thing. We know we are going to use first quadrant and fourth quadrant. So but you just use one of these, you'll have your answers. Okay, so for this one, we have to find firstly reference angle for this. So your reference angle will be cos inverse of 1. So cos inverse of 1, this will be 90 degrees. That's cos inverse of 1. Am I correct? Cos inverse of 1. Yeah. Cos 0 is 1. Okay, so cos inverse. Oh shit. This is 0 degrees. So we have that cos inverse of 1 is 0 degrees. So we are going to use quadrant 1, which it says what? It says theta equal to what? Your reference angle plus 360 times k, for k is element of integer. So in this case, your theta is just x, which equal to your reference angle is 0 plus 360 times k. So that's the answer, 360 times k. So there's no need for us to go to the fourth quadrant, but if we go to the fourth quadrant, it will just give you 360 plus 360 times k, I think. Yeah, so that's the general solution for the first one. Okay, so now we have the second question. It says find the general solution for this one. 4 sine squared theta equal to cos 90 minus 2 theta. So in this case, we can clearly see we have this one here, 90 minus 2 theta, and we have a double angle, and we have 90 here. So firstly, we have to sort these things inside the bracket. So 90 minus 2 theta, cos of 90, this changes cos into sine. Because it's minus, it's in the first quadrant, so cos will be positive. This will be 4 sine squared theta equal to sine 2 theta. Because this is positive, because of 90 it changes to sine, and it's in the first quadrant. 90 minus is first quadrant, so everything is positive. So we have this, but we have double angle and a single angle. When we have double and a single angle, it's important for us to just change one of these. So it's the best way is to change the double angle into a single angle. So this will be 4 sine squared theta equal to 2 sine theta cos theta, because we know the double angle for this is 2 sine theta cos theta. So we see squared. When you see squared, you move everything to one side. This will be 4 sine squared theta minus 2 sine theta cos theta equal to 0. So now we have two terms here. So when you have this, you have to take out the common factor. In this case, common factor we have is 2 sine theta. So we are left with 2 sine theta minus cos theta equal to 0. So in this case, we can just solve for theta. This will be 2 sine theta equal to 0, or 2 sine theta equal to minus cos theta. So we have these. We can just divide by 2 here, then sine theta will equal to 0. In this case, when you have sine and cos, divide by cos. Since we know if we divide by cos, this will be tan, and these cos will cancel. You see, when you have sine and cos in opposite side, you just divide by cos. So this will give us 2 tan theta equal to -1. But we don't need this 2 here. Divide by 2 both sides, then tan theta will equal to -1 over 2. So we can find a general solution for this. For sine theta equal to 0. So sine theta equal to 0. So this will use first quadrant, because 0 is neither positive or negative. So we use the default one, which is first quadrant. But there is an exception. When sine is 0, our normal period, it changes into 8, because for sine to touch 0, if I draw this, this is graph for sine. It starts from 0, the normal one. This will be 1 1 0, then it goes again, it says 0. This is 0, this is 90, this is 180, this is 270, this is 360. So from this 0 to this 0, do you see the period is 180 degrees? That's why they say period for when it's 0, it's 180 degrees. From this 180 degrees to 360, that's 180 degrees. So you see, we touch 0. For every 180 degrees, we touch 0. So that means when you find this, let's find the reference angle. The reference angle for this sine inverse of 0, which is just 0 degrees. Then we use quadrant 1. Quadrant 1, it says what? Write down your angle, then equal to what? Your reference angle plus your period, which is 180 times what times k, for k is element of integers, then that's your answer. You can just simplify it. 180k 180 times k. So that's your answer. So we can go to this other one here. Let's separate it so that we can see. So for the period of tan is 180. So this we use what? Tan is negative in the second and fourth quadrant. So it's negative in the second and fourth quadrant. That means the general solution will be in the second and fourth quadrant. So this one we say the reference angle for this, which will be tan inverse of 1/2. The negative was only helpful for us to find which quadrant is tan negative. So this will give us the tan inverse of 1/2. What is tan inverse of 1/2? Okay. Okay, that's 26,57 degrees. So it's 26,57 degrees. Okay, so we'll go to quadrant 2. Quadrant 2, this will be what? Our angle, this angle here. If it was 2 theta, we'll write 2 theta, but now it's just theta. Our angle equal to what? Second quadrant is 180 minus the reference angle. We subtract the reference angle, which is 26,57 plus what? The period is 180 degrees times k. For k is element of integers. So we have this. Our theta will equal to what? Let's see. Okay, that's 153,43 degrees plus 180 degrees times k. So we have that, the second quadrant, and we can go to the fourth quadrant to just list all the quadrants that will give us solutions. So for the fourth quadrant, but it's not important for you to do these two. If you did only one, it's okay, but for learning purpose we do all of them. So quadrant, this will be fourth quadrant, this is 360 minus your reference angle plus 180 times k. Okay, it's element of integers. So these are angles. This will give you 360 minus 26,57. That's 333,43 plus 180 times k. So this is the general solution of this, of 4 sine squared theta, which equal to cos. Yes. Okay.